Okay, this video is going to be about Boolean operators and Boolean expressions. I have an Atom project set up here, and this file I'm looking at is booleanoperators.js. Okay, if I type ls in the command line, Boolean operators. So this is a JS program, and I've written it so it works with Node.js. So the command to run JavaScript from the command line is node and then the name of the file. Okay. So Boolean primitives, they are true and false. And it's important to understand how the computer stores these values. In binary, which is 0 and 1s, false is 0 and true is 1. So in memory, that's how these are stored. These values are stored as 0 and 1. Let me run this again. Let's see, false equals 0. False equals 0. And this is an expression that evaluates to true. Most of the time we do not ever use double equals, we'll always use triple equals. In this case, there are some cases where you do use the double equals. The point of the double equals is it coerces the value into a different type. Okay, so this is a Boolean value and this is a numeric value. So the double equals will coerce the types so that they can be evaluated. So like if I had a value that was a string 0, if I add 0 to it, it coerces the type from a number to a string, and the output here would be 0, 0. Okay, so to avoid all the pitfalls that come with type coercion, we're just going to use triple equals most of the time. But the point being here is that false is synonymous with 0 and true is synonymous with 1 in memory. Okay, let's look at some of the Boolean operators. The simplest is the not operator. It basically negates the value of the Boolean. So it makes true false and it makes false true. The not operator is an exclamation point. You put it in front of the value you're trying to negate. Okay, so here's a truth table. It's really simple since it's a unary operator. It just takes one parameter, either false or true. And if you not false, you get true. If you not true, you get false. Now it's important to recognize that true and false are synonymous with their binary equivalents, so I write the binary truth table as well. So 0 turns into 1 and 1 turns into 0. It's the opposite. It negates the value. Okay, so here's an example of using the not operator. It goes in front of the value or expression you want to negate. So not false, this should be true, and not true should be false. So not false is true, not true is false. Okay, so not 0 is true, and not 1 is false. Okay. Alright, that's nice and easy. So let's get on to the more complicated operators. The AND operator. This is a Boolean operator. Ampersand is the operator you use in code. And it has a left-hand side and a right-hand side, which means it takes 2 arguments. Okay, so the truth table gets a little more complicated. So if we have false and false, we get a false. If we have false and true, we get a false. If we get a true and false, we get a false. And the only way we get a true is if it's true and true. Okay, and you can think about this logically just using language. If this is true and this is true, then the whole thing is true. Right? If I like blueberries and I like muffins, then I probably like blueberry muffins. So if they're both true, then the whole thing is true. Okay, so it's a binary operator that returns true only when both the operands are true. And then here's the binary equivalent. So false is replaced by 0, true is replaced by 1. So 0 and 0 is 0, 0 and 1 is 0. You see the only time you get a 1 is if it's 1 and 1. Okay, and this is an example of using the operand, or the operator with operands. So this is false and false, false and true, true and false, true and true. So you should see what we get in this truth table from this code here. False and false is false, right? That's in our truth table. False and true is false. So false and true, that's false. True and false, true and false is false. That's correct. And then the only one that returns true is true and true, which that's the same in our truth table. And then the binary version is the same thing, just using numbers. Okay, so that's the AND operator. It's only true when both things are true. The OR operator is true when at least one of the things is true. The only time it's false is when neither operator is true. Okay, so this is the OR operator. It's designated by 2 pipes. The pipe is usually right above your enter key. You have to hold shift. It's shift and the backslash key. And you do that twice, just like AND. The AND operator is 2 ampersands. The OR is 2 pipes. Okay, so the truth table. If you think about it again logically in terms of language, if this is true or that is true, the whole thing is true. Okay, if one or the other is true, that's fine. It satisfies the Boolean expression. Okay, so false and false, or I'm sorry, false or false is the only outcome that is false. So this is the OR truth table. So false and false or true here is true. True or false is true. True or true is true. So again, with OR, just at least one of them has to be true. They can both be true, it doesn't matter. As long as one of the operands is true, you return a truthy value. Binary truth table looks exactly the same, except you place true and false with 1 and 0. Okay, so this is how you would write out the code. This is a Boolean expression. On the left hand side, we have a Boolean value, false. We have the Boolean operator in the middle, and on the right hand side we have a Boolean value, which is false. So these are binary operators because they take two operands, a left hand side and a right hand side. Okay, so false or false should give us false, and then the rest of them should be true. Okay, here's our Boolean truth table for OR. False and false are the only ones in the OR truth table that give you false. Sure enough, the first one was the only one that gave us false. Same with the binary. 0 is false, 1 is true. Okay, that's not too bad. Next, the equality operator. We've already discussed this a little bit with numeric values, but you can use it the same way for Boolean values. Okay, it's triple equals. That's the operator in JavaScript. Again, don't use double equals unless you're absolutely certain you need it, and in almost every case you do not need it. So always use triple equals. Alright, so here's the truth table. Basically, if the two values are the same, you get a truth. If the two values are different, you get a false. So false, false is true because they're the same, and true, true is true because they're the same. Okay. This again is the JavaScript Boolean expression. The triple equals is a binary operator. It takes a left-hand side and a right-hand side. Those are the operands. Okay. So false equals false. That's going to result in a true. This one, false equals true. That one should result in a false. True equals false. That one should result in a false. True equals true. That should be true. So we should have true, false, false, true here. True, false, false, true. Okay. The equals is simple. It's just what you would expect. Does this thing equal that thing? Are they the same? True or false? And then not equal is just the opposite. Okay, the not equals operator, the first equal sign in the triple equals is replaced with the not sign, which is exclamation point. So exclamation point, equal, equal. That means not equal. Alright, and the not equal truth table is basically if the two things do not equal each other, it will return true. So false does not equal false. Well, false does equal false. So false does not equal false is false. Okay. True does not equal false. That's true. They do not equal each other. False does not equal true. That's true. They do not equal each other. True does not equal true. That statement is false because they do actually equal each other. Okay, so this is how you use the operator. Left-hand side, right-hand side. Operator in the middle. It's a binary operator. And this whole thing is a Boolean expression. We talked about JavaScript expressions. You can have lots of operators in these expressions. So I can put parentheses around this and say or true, and then put parentheses around this and say equals 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 false, and then put parentheses around the whole thing and add a not character in front. Okay, so you can do very complicated things with these Boolean operators. You're not limited to just left-hand side, right-hand side, and you're done. Using parentheses, you can have very complex expressions. So let's put this back to how it was. So we should see not equal. We should see that should be false. True, true, false. Okay. And it's important to note the not equal is just the same as doing triple equals, but with a not sign in front. Okay, so if I duplicate all this, okay, so this is the same as notting, which is negating the equality operator. So if instead of not equals here, I use equal equal, but I put these in parentheses, and add a not in front, we're essentially saying the exact same thing. We're saying the inverse of if they're equal. So negate if they're equal. That's the same as saying not equal, right? So the results here should be just the same as the results up here. False, true, true, false. Okay, and it's negation, so it's similar to, adding a negative or subtracting. Negation is basically like in math, just putting a minus sign in front of something. So if I have a negative 4 plus 5, you distribute the negative in there. Right? So you get rid of the negative and add the negative to each term. Okay, so you do the same thing with Boolean logic, and we'll go into more of that, how you can translate OR statements to AND statements and different stuff like that in another lecture. Okay, so these are the most basic Boolean expressions. With all of these, you can do extremely complex Boolean logic using parentheses and make very complex expressions for practically everything you need. Alright, that's it for Boolean operators.